Yeah.
My elementary school level understanding of the singularity is like there's no known thing that stops the collapse of the thing,
Yeah.
and which is why we have a singularity. What if we're just ignorant? Like if we didn't know about electron degeneracy pressure, wouldn't we just say a white dwarf becomes a black hole because we don't know what stops it from collapsing? So why is everybody all bent out of shape about the singularity? Maybe the answer is just we haven't don't know enough about matter to know that there's something else that stops it from collapsing all the way, and that at the center of a black hole there's a thing that's this
Well,
big.
right, but no, but in GR, if you're inside the event horizon,
Yes.
every particle's path leads to the singularity. So there are no world lines that don't end in the singularity. So there's not so it kind of doesn't matter. Like if GR were entirely correct, which obviously it's not, but if it were entirely correct, then there would be no choice but to have eventually everything at the singularity. Either
Yeah.
so there's no like extra. It doesn't matter what extra physics is there, as long as it meshed with general relativity, which of course quantum physics does not, and which means there probably is something like that. But uh,
Where does my world line end as a human being right now?
and I don't know,
I
probably
don't know.
eventually in the singularity of a black hole.
Yeah. All right. We got to get started. Here we
Okay.
go.
Oh,
Everybody ready?
she's here. Okay.
Yeah.
I'm ready. Can you hear
We
me?
can't hear you. Oh yeah. Okay, we can hear you. All right. You
Okay,
ready?
good. Oh, yeah.
Welcome to Walkabout the Galaxy, the fun astronomy podcast where the science is universal, the opinions are personal, and the takes are hotter than a supernova. We are strange down and not one top, but two, the astroquarks, also known as Josh Caldwell,
Audrey Martin.
Jim Cooney.
And Tracy Becker.
coming to you from distributed locations around the internet. Follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram, where the facts aren't checked, but you can count on ours. So like and share and tell your friends about the astronomy podcast for people who don't really care that much about astronomy, and for people who do care about astronomy because we do eventually get around to it. Catch our videos on YouTube. We are at Walkabout the Galaxy, and you can email us at wtg@ucf.edu, where if you send us a comment or send us an email, you'll be a talkie walkie. I don't know
What?
if we got
What?
buy-in from that. Well, our fans are walkies, right? Walkabout the Galaxy.
Oh, is
So
that what they're
you,
called?
they're called walkies. You know how fans of BTS are called Army, fans of Taylor
Okay,
Swift are called Swifties.
I
I'm
knew
sure
that.
you all, of course, know that fans of Rolling Courts are called diadems.
Are they?
Not, they are. That's a little bit sad, I confess. Fans walk about the galaxy, I think, should be called walkies. They can't be called walkers because of The Walking Dead. And if they talk to us, then they're talkie walkies, right?
I love it.
Yeah.
Okay.
Uh, Our stumper today is celestial sightseeing, old Jim.
Okay. I want to go.
You get you get to see one of these in your lifetime. Which do you choose? I'm going to give you three choices. Two of them are like plausible, and one of them is not. A daytime comet. So just a really what is sometimes called a great comet. So a comet
Okay.
that's big, bright, beautiful comet. You can see it in the daytime. A daytime supernova. These have also happened. That so appears and it's bright enough, brighter than Venus, bright enough to see in the daytime sky. Or we're going to presume, for the sake of the stumper, that you're so remarkably lucky and have such excellent sense of timing that you happen to be looking at the moon, your choice, whether it's with an unaided eye or through a telescope or binoculars, at the moment that a really big, whopping object slams into it and produces a fireball, visible molten rock impact crater souring over the moon. Doesn't destroy the moon, doesn't break it apart, no danger to anything, but a big old whopping giant impact that you can see from here on Earth. Which celestial light show would you most like to see?
This
and I will
isn't
do
even.
my best to make it come true for you.
Okay. This is not even close to a stumper. A lunar
Huh.
impact would be so cool.
Okay. What's the downside, of course, of that one is like it's over in a couple minutes or something. However long it takes for the ejected to fall back down, then it's over.
A supernova is just a bright dot in the sky.
Yeah, you hate to see Audrey be wrong, but there it is. It's in fact the supernova is the right answer.
The
Oh,
supernova is the right answer. Why
Yeah.
is that?
Well, just because it's badass. I don't know. It's a supernova that's going. I mean, first of all, they can be really bright, like full moon bright, like if Betelgeuse goes or something like that.
Yeah.
And, it would last a month or two. That you'd be able to see stuff. It would be really cool.
Okay.
I'd go
Uh,
Comet.
All right, we got all three. I love it.
we got all three.
Yeah.
Nice.
Tiebreaker, Josh.
Um,
Moon,
I
moon,
think I'm
moon,
going to go
moon.
Comet.
Ah,
I'm going to go Comet because it's going to be changing. You know, it's physically the largest of these things. It'll be a big thing on the sky and to look cool through a binoculars or telescope as well as to the naked eye. The supernova is like cool, but it's ultimately just a point source of light. And so,
Yep.
you know,
Yeah.
yeah.
I think the comet, other people would also notice it. It would get a lot of people excited about astronomy. Everyone would be like, "Oh, what is that in the sky? Oh, what's a comet? Oh, cool.
But if
Now we know
the
all
moon
about it."
was if
Oh
the moon was
boy.
impacted, nobody would notice.
Well, it would happen, like we said, it was in an
They,
instant,
we're,
so not
yeah,
most people
you're,
wouldn't get to see it.
but somebody would have recorded it. So thered be a lot of video
There'd be some
out
good
there.
YouTube videos with
There'd be
some
some
Oh
good
nice
yeah.
like
videos.
TikTok music in the background, you know.
Yeah.
hmm
Yeah.
Russian dash cam footage.
Yeah. Well, today we will talk about supernovas and interesting exoplanets. But first, this episode of Walkabout the Galaxy is brought to you by Type 2 supernovas. If you need a standard candle, get a Type 1 supernova. But to meet your heavy element needs, nothing fits the bill like a Type 2 supernova. Featuring rapid neutron capture in this spectacular stellar explosion, the Type 2 supernova can replenish your coffers of gold, platinum, uranium, and even copper and nickel. So get ready to mint some coins with a Type 2 supernova. With more energy output in a few minutes than the sun produces in 10 billion years, Type 2 supernovas can also solve your energy problems. Brighten your life with a Type 2 supernova. Always maintain a safe distance of several thousand light years. Protective materials sold separately. Type 2 supernovas. See where no one has before.
uh,
Uh, Telescope, some kind of telescope or flashlight.
I was thinking about a flashlight. Yeah, but like I don't know what a flashlight company is.
You don't?
Coleman. Coleman.
Coleman? All right, that's a reasonable guess.
Okay.
Tracy, any ideas?
Uh,
See where no one.
what's the
See
smelly
when.
candles?
Yankee
Oh,
candles.
Yankee candles.
okay. I thought you
It
were going to
it
be.
makes light. I see the
It makes
logic there.
light, and
It does.
and then the Type 2, are they not the standard candles of the galaxy?
No,
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 no.
the
darn.
Type 1A.
Oh,
The
well,
Type 1A. You obviously
it's
weren't
close
even
enough.
paying attention when I just read the sponsor message, which said, if you need a standard candle, get a Type 1 supernova. But if you need other things, get a Type 2. Thanks for paying attention.
Yep.
Huge fan of the
What
show. She is huge fan.
She is a huge fan of the show. She listens very carefully to the last 5 seconds of every episode as it's going. So she only has what has been said in the last 5 seconds in her
Yeah, it just
head.
skips every few seconds.
Yeah, it's like one of those. Yeah, it's like one of those recording things that just like constantly taping over itself. It's like got a storage capacity of 10 seconds. So she's already forgotten the beginning of this paragraph. Um, but no, what I love is that when you said smelly candles, you were thinking of what are supposed to be good smelling candles. I was thinking of what's that thing they get, like the stuff you burn to try to keep mosquitoes away?
Like
Oh,
incense?
Citronella.
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 Citronella. Yeah.
Citronella. You said smelly candles. I'm like thinking a citronella candle. That's not like a light. It's not known for being like a source of light. Jim wins this one. It's closest to it's Sylvania off road. So Sylvania's, off road
What?
light emitting. What do you mean? What?
What's it's Sylvania?
Sylvania makes lights, Sylvania light bulbs,
Oh, okay.
and they have a brand of things that are for like flashlights or lanterns or camping or things of
Oh,
that nature. Yeah. So
okay.
anyway, I think so. Jim, you've got a hot take, I understand.
Hot take.
Hot take.
You
Hot
want to go first, Beth?
take. All
Go
right.
for it.
No, but my hot take is a bummer. But I'll
Okay.
do it anyway.
No.
A bummer? Like you mean it's a sucky hot take or it's going to depress us?
Probably both. It's going to it's
Oh,
yeah.
great.
My hot take is this: we are the only sentient species that has ever existed in the universe.
Yeah, I was afraid you
Can't
were going to
accept
say
that.
that.
I'm like, the more I learn, the older I get, the more I think about the Fermi paradox, and the more worried I become that in fact we are alone in the observable universe, and I don't like that because we're trying to kill ourselves so very badly.
Yeah.
Uh,
Yeah.
so
Unfortunately, I'm on the same wavelength as you are. So
yeah,
can OG top or down
yeah. Cheer
help
us
us out
up,
with cheer us
Tracy,
up and
I think
convince us
Audrey.
that we're overly cynical?
it's so hard to detect life in any form that ruling it out completely is
I'm not
as
saying
Sentient.
plausible
not
as
He
not
said
saying
not
he
no
said
life. I
sentient.
bet that there's teeming with
no,
life
no.
out there,
Okay,
but
yeah,
I'm talking about
sentient life.
sentient, intelligently. Yeah,
Yeah, but ruling it out entirely seems like a unnecessary. You don't have to rule it out. It's so hard. Yeah, it's so hard, and it's a big universe, and it's also like why would it just be here? It seems a little self-centered as well. So I don't buy it. I'm not on the team of it's just us.
I'm sorry, you didn't cheer me up. Tracy, can you do a better job of cheering me up?
Well, I'm with Audrey on that. It's the odd. I mean, I think just statistically, right? You guys love statistics. What are the odds that it could only happen one time in all of the teeming places of life? I mean, it wasn't like there were a handful of probably pretty crazy circumstances that happened here, but why would that not also happen at least one other time, if not probably millions of other times somewhere else?
So yeah, so my modified hot take on Jim's hot take is not that we're the only sentient life form that has ever existed in the observable universe, but that we're the only sentient life form in the Milky Way at this time.
yeah. That might be a more
And
reasonable.
I think that addresses a lot of the sort of statistical and other things. And of course, one of the factors in the Drake equation, which predicts how many of these things are out there, is how long do these civilizations last? And for search for extraterrestrial intelligence sort of relies on rockets and radio and things like that. So in those terms, we've only existed for like 100 years, to the nearest
Yeah,
order of magnitude. And I don't know how promising it's looking to make it to the next order of magnitude, to be quite frank. So,
yeah, yeah.
well, I've got a different hot take that's not depressing.
Oh, good, 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 good.
So I'm glad we got yours out of the way first,
Hit me.
Jim.
Yeah.
It's supernovas, not supernovae or supernovae or
Why?
supernovae, because we're speaking English, Audrey. We're not speaking Latin. We don't live in ancient Rome. So if you live in ancient Rome, you can say supernovae with an AE at the end. But I'm speaking English. I don't know what it would be in a different language, like if you're speaking Navajo or Korean or any other of a number of languages that I have no knowledge of. But in English, a plural gets an S at the end. And I don't see
That's
why
just not
novas are so special that they get to have a Latin ending. And it's awkward, and I don't like it.
Because the main part of it is also derived from Latin, right? Nova.
50% of our words are derived from Latin.
Yeah.
exactly. English is a hodgepodge.
Right. And we took all those words that we derived from Latin and we anglicized them.
So what's when you see
We put an S at
multiple
the end.
what's multiple aurora?
Auroras. Hot
Okay.
take. Hot
Josh,
take.
I'm with you. I'm with you, my friend. This time,
Yes.
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 English is very frustrating that we do that. Let's make things simple. All plurals should just be S.
An S.
Yep.
Cactuses.
Yes.
Yeah.
Yes.
Yes.
I'm okay
Cactuses.
with
Yes.
that being a thing. I have a hard enough
Yes.
time with just grammar in general, full
Yeah.
stop.
Right.
So making it
Yeah.
simpler is great,
Plural
but that
S. If
isn't
it
what
ends
the
It
with an
rule
S,
starts
is.
here on Walkabout the Galaxy.
All
if the
right,
word,
I'm
if the
gonna go to
singular ends with an
Alaska.
S, it's an ES. Otherwise, it's just an S.
By the way,
I'm
both
gonna.
are acceptable in Scrabble, the E
Oh,
or the S.
that is good to know.
So yeah,
So,
What about
well,
mooses? Is that
yes.
acceptable in Scrabble?
I don't know, but it's acceptable here on Walkabout the Galaxy.
Hot take. It's
I think.
mooses and gooses
Yeah.
Mooses and
and
gooses.
mouses.
Can our listeners be called mooses and gooses? I think that's cuter
Uh,
than walkies.
really? What's
Yeah.
Walkies is cute and it makes sense.
Listeners,
L-
weigh in.
Listeners,
What do
weigh
you want
in.
to be called?
Be a talkie-walkie and let us know. Space news, as you may know, the Axiom 4 private human mission to the International Space Station, which is a SpaceX launch vehicle, uh, was delayed first by some leak on the ground and now by a leak up on the International Space Station. So that's been postponed indefinitely. Um, we've talked ad nauseum about Starlink launches. This is the SpaceX satellite network of internet satellites in low Earth orbit. Just quick bonus trivia. How many of those are up there now? Any, do you know?
100,000?
9,000.
5
That's
million?
adorable.
A billion?
Tracy, you want to shout a number out?
1,500.
Jim gets it. Way to go, Jim. It's 7,600, which is insane.
That's like
Um,
kind of close to what I said, but
and
You could have gone with a gajillion. That works too.
a gajillion.
yeah, I could have said a gajillion, but I didn't.
You were much more
Uh,
precise than that.
Amazon is starting to build up their own network for internet satellite service. It's called the Kuiper network. That's Q-U-I-P-E-R after the astronomer Jared Kuiper. Their first batch of about 25 or 30 satellites went up a couple months ago. Their second batch out of a planned 80 some launches and a total number of only 3,200 satellites is scheduled for a few days from now. So by the time of this episode airing, that may have happened. And they are also announced some more details about their sort of planned architecture for sending stuff to the moon, a vehicle that would like be a tugboat or a fuel tanker that takes materials and fuel from low Earth orbit to lunar orbit for lunar landers to tank up on. And they're saying, believe it when I see it, that they will be landing on the moon by the end of this year. But their big launch
Whoa.
vehicle, the New Glenn, has only flown once several months ago, and they've recently just postponed the second test flight of that till August. Um, so I think it's more likely to be next year. Um, okay, so we've been talking a lot about supernovas, and we've actually got our first topic deals with these. So, uh, Jim, remind us about the different kinds of supernovas. They were mentioned in the podcast in the sponsor message.
Yeah, I mean, the simple version is there's a massive star supernova, which is when big stars die, they blow up very violently. Those are the type 2 supernovas. And then there are white dwarf supernovas, which happen when white dwarfs collect too much material and then freak out and go thermonuclear and blow up. Totally different mechanisms, but very similar observable phenomenon. You know, like an otherwise fairly dimish star, or not necessarily dim, but an otherwise normalish star goes crazy and gets really, really bright for a few weeks and then dims down.
Fades away.
The white dwarf supernovas are sometimes called type 1 supernovas. You know, obviously you can get finer, and there's type 1A and 1B, and et
There's a
cetera. But
gajillion
who cares?
letters
Yeah,
they add
yeah.
onto these
But,
things. Yeah. See how see how I
those
worked gajillion in there
gajillion, yeah, yeah.
organically.
Very good. So, either one, if they go off in your neighborhood, you're in some trouble. And I guess that's what this article is about.
Yeah. So there's a new study that's sort of taking another look at the possible terrestrial environmental effects of nearby supernova events. So, um, and it's looking at very, just the recent record. So the last 50,000 years or so, what's called the terminal or late quaternary period, but basically roughly coinciding with the appearance of modern humans. And there have been like the big mass extinction events that we've talked about before, which many of which are related to like a thing hitting the Earth, like an asteroid hitting the Earth,
Hmm.
related to the big extinction event that took out the dinosaurs 65 million years ago. And there were others of those longer ago. And there are also various uh, signatures in various records, uh, isotopic records from ice cores and things like that, and climatological records that we can piece together that could potentially be related to supernova going off nearby. And so in this paper, they take a look at um, sort of updated timing and distance of the supernova events in the our corner of the galaxy and the various markers of what has happened in our uh, environmental history, like isotopic changes. There have even been some sort of like minor mass extinction events. I guess that's an oxymoron, but where a big group of species sort of went extinct in a short period of time, but not like 75% of all species on the planet kind of thing. And find some some indications that events as recently as within the last 10, 20,000 years may be related to nearby supernova events. And of course, it's interesting not just to sort of understand what's happened in the past, understand what produced those extinction events, but you mentioned Betelgeuse earlier, Jim,
Yeah,
as a star
the thing
that's
is ready to go.
in our neighborhood and it is ready to go. Within the next, what are we talking for Betelgeuse, 100,000 years
Hundred
ish or
thousand issue.
something like that?
Right.
Yeah, that's the blink of an eye.
It is. It
Getting that,
is.
you know, and it would be a big deal.
Yeah, yeah. I mean, so I think that in here there. I mean, to be truly dangerous, you got to kind of be within 1,000-ish light years or something like that. It was the numbers that I think I. Betelgeuse is something like 700 light years away, which means probably it's not going to be on the level of some of these things that they're talking about, but it will have some effect for sure.
Yeah. So, for example, they're looking at the carbon 14 events, so changes in the chemistry of the atmosphere 9,000 and 7,000 years ago. Um, they can tie to nearby supernova events. Um, Once a supernova is more than several thousand light years away, as you said, it's probably not a concern. And also, the radiation from a supernova sort of d- blends into the background radiation of the galaxy after several tens of thousands of years. So, this really you can only look back a few tens of thousands of years, which was done in this study. This is relatively unusual these days to have the single author paper. This is by Robert Brackenridge at University of Colorado, um, and he's at INSTAR, which is an Arctic Ice Institute for
Oh.
yeah.
Ice people.
So
Ice people.
yeah,
Yeah.
right. Yeah. So he's very familiar with what those ice core records and bubbles say
It always
about
Hmm.
amazes
the
me how
climate.
much you can learn by just digging a core of ice, right? Like, I mean, with those little, what is it? It's typically
Yeah,
little air bubbles trapped in the ice from
right.
thousands and thousands of years ago. You could tell what the atmosphere was like. That is awesome, I think.
Right. Yeah. I mean, that is largely due to isotopic fractionations and ratios of different isotopes of the same elements, which are controlled by temperature and chemistry at the time. And so, but they also like have tree ring data. They have uh, other, and then the fossil record, of course, to tell you what's
Mhm.
going on there as well. And we know things about sea level and all that stuff. So supernova. So maybe we want to, you know, Jim, you wanted to see a daytime supernova. You might want to reconsider that.
Reconsider. Yeah.
Yeah.
This is it's
This is
kind
one of
of
the. Go ahead, Audrey.
the we talked about a similar story like a month or two ago where researchers were going through data to see how frequent I think supernova events were, and it seemed like there should have been two in the geologic history of the Earth, and they kind of align with mass extinction events. So this is like actually looking at other data on Earth and lining it up.
Well, like Tracy, although my repeating loop is longer than 10 seconds, but it doesn't extend long enough to remember exactly what the details of that past story were.
Yeah, it
But
was they
but
were
the
they were
number,
astronomers, so they didn't there wasn't any like actual geology in it, if I
it,
remember correctly.
right.
But they do just the frequency lines up with two extinction events. I don't remember which ones they were. Um,
Yeah,
but
and
they're
I
in the
think,
geologic record, whereas these seem
yeah,
to be
I
maybe more
I
geologically recent if they're in tree ring and ice core
I believe
records.
those were referring to gamma ray bursts or something. I think it may have been something, a different
Oh,
class of
okay.
event than supernova. The list of supernovas that are looked at here is in the tens within within the last 50,000 years.
Okay.
So
Different
there have
data
been a
set.
lot.
So maybe
There's
different.
been a lot of supernova, like there, table one of the paper, nearby supernova remnants, neutron star black hole distances and ages. There's 78 of them within 2.3 kiloparsecs, which is about 8 light years or so. So sorry, 8,000 light years. Sorry.
So
So that's a lot.
I have a hot take go back because while these events could be causing small mass extinctions, they could also be depositing energy into other worlds and helping to trigger life to form, right? When you get those bursts of radiation or some sort of new energy introduced to a system, it can also add to the chemistry in a positive way for life.
I love your optimism, Tracy Becker.
Yeah, you are such a sunny, bright,
Oh
positive
no.
person. But usually the the stuff coming from supernovas is bad stuff. You know, it's high
Yeah,
energy.
but if
Uh,
it goes, so like you could have it hit like a very thick atmosphere planet, and then it just kind of enters into the chemistry of that atmosphere that then gets kind of trickled down, or if it's more like an ice world that it, triggers a new batch of different chemical reactions that then get somehow sunk into the ocean underneath that ice. Never know.
Yeah.
There
Yeah.
could be
I,
some
it,
positive effects.
energy is widely, an external source of energy is one of the necessary ingredients for life. So, let me
It
give you
it what they were
your.
supernova events, and it was
They
the
were.
Devonian and Ordovician.
but they must have been very close by, right? So close
I don't
by
know.
supernova events could cause extreme, very significant extinctions. But I guess the cool thing about this is more distant
More
ones,
distant
moderately
ones.
distant ones, could still have significant effects on our atmosphere and climate.
Yeah, those
Yeah,
must have been like within light years, like ones or tens of light years instead of hundreds or
yeah, that's
thousands
bad
of
news.
light
Very
years.
bad
And do
news.
we
Yeah.
have like, so if that were to happen now, I mean, we would see it in the sky too, but would we have like, I guess we would have the devices to measure the uptick in radiation and like let people know that they should start wearing like lead shirts or something for a little while, or would we just not even know it's happening?
I think
Well,
the
we
biggest
would know
problem
it's
is,
happening.
yeah, the biggest problem is not really that. I mean, for those kids, it change the climate, right? So it does
Yeah.
things like strip the ozone layer and
Yeah,
cool the planet a little bit. So these, we would probably be okay,
Okay.
humans, because we can adapt to that. But creatures who can't, as we're seeing in the world now, as we warm it, you warm or cool something reasonably quickly, you're in trouble.
yeah. So let me give you your trivia, and I'll tell you what your trivia might have been, but isn't because it relates to both Tracy and Jim's comments there about bright daytime supernovas. The brightest observable supernova that we know of for in sort of modern human history, was a daytime visible supernova. And it was in the year roughly 1,000 uh, or so. Do I have the age here? I don't have it written down. It's not the one that made the crab, but it was like 50 years before that. So just about 1,000 years ago. And it was brighter than Venus, visible in the daytime sky, not as bright as what Sirius would be, I think,
You
though.
mean Beetlejuice? Yeah,
I mean Beetlejuice.
yeah.
Yeah, sorry. Well, wow. Okay, here is your trivia. It is supernova related. The amount of energy released in a supernova is so large that a new unit of energy was coined by Gerald Brown and Hans Bethe, and it's equal to 10 to the 44 joules. So joule is a small amount of energy. There's 4,000 of them in a food calorie. So a joule's not a lot of energy, but 10 to the 44 is a big number. It's a one with 44 zeros after it, and a food calorie is just 1,000 of those, one with three zeros after it. So this amount of energy pops up a lot in supernova calculations. So the type 1 supernova all have the same amount of energy. Um, so, and coincidentally, by the way, it's the same amount of energy roughly that the sun will produce in its entire 10 billion year lifetime. So it's a multiple choice. Remember not to blurt your answer out now. We'll come back to it after our next topic. What is the name of this unit? And here are your choices. The beta, that's after Hans Bethe, Bethe. The foe, Foe. A whopper, a slam, a chandra, or a crab. One of those is a unit of energy roughly equal to the amount of energy produced in a supernova. We'll take a quick journey to exoplanets and then come back to that and get your answers. We've talked before about some of the funky kinds of exoplanets out there, and they're weird in many different ways. And it kind of gets to Jim's depressing hot take because, for various reasons that are understandable, we haven't really seen planetary systems like our own. We've mostly seen ones that are very different from our own with very hot planets. When we get hot planets, you can get some weird weather.
Yeah.
I'm looking at you, Tracy.
It turns out that sand can be in the forecast. So
Sand in the forecast.
What?
So, yeah, there are these exoplanets that they found using, but they studied with JWST. I'm sure they had already found them, but they were looking at them with JWST, so they got very high spectral resolution information, and they detected silicates, both in the circumstellar disk where the planets are actually forming, because it's a very young system, so the material that's kind of orbiting the central star still hasn't fully dissipated yet or gotten incorporated into all the planets. So these planets are forming. They're giant ones. They're 14 times the size of Jupiter or something like that.
The disk is still there,
And the disk is still there. So
basically.
they're kind of
Yeah.
forming inside of this disk. So we kind of get a snapshot of like a baby solar system, which is fun. But top of that, they've never really seen sand or silicate in circumstellar disks before. I think partly just not having the resolution or partly not looking at these systems yet. But so some of this sand is actually just kind of flowing into the atmospheres of the planets. And then in one of them, it was saying that it even is going through like cyclical processes like it would water on Earth. But these are gas giants, so it's not like it's solidifying or turning into liquid probably, or maybe it gets deep enough to turn into liquid and then re-evaporate up into a higher layer of the atmosphere. It's not clear to me from the main article that I'm reading, but
Well, one thing we know about sand, it gets everywhere. I hate it.
the article does make a lot of references to whether Anakin would enjoy this world or not, which is fun. But yeah, so there are these sand clouds in the sky. So
So sandy with a chance of meatballs or something.
yeah,
Yeah.
Is it?
Um,
I'm looking at the article now. Do they talk about the actual particle size? Because sand is a specific particle size. So it would be
that's
wild
true.
if they were all the same size. bits of
How
silicon.
big is sand? What do you mean sand is specific? How big is sand?
There's sand. It's like what is it like maybe 1,000 microns
100
to like
microns to a millimeter.
it's definitely bigger than
100,
100 microns.
it's
My
100 to 1,000 microns.
Is
my
that what it
As
says
guess,
I,
on the
that's
website?
what I say. That's
It's
what I
bigger
say.
than 100.
but my guess
Okay,
is that it's
250
silicate.
to 1,000. It's sandy composition.
Yeah, it's anti-composition, and it's
Okay.
probably a
Oh,
Right.
range of particle sizes. And so the thing that people can actually understand instead of reading about silicates would be sand. At least it gives people something that they can imagine in their
Right.
brains.
But in larger chunks, we would call that a rock,
Yeah.
right? Like a lot of rocks, correct us, geologist Audrey. Like most rocks are I mean, a lot of rocks are, is this fair to say a lot of rocks are silicates?
yeah.
Yeah.
Yes, it
And I
is.
think we
Yeah.
have talked about exoplanets with rock clouds before.
Yeah.
If you get some of these things really close to their star, and this one is in a forming planetary system, but a lot of exoplanets that we've seen in mature systems or even old systems around ancient cool stars have these hot Jupiters that are so close into the planet that you could potentially have that, although typically the composition isn't sandy
So
or rocky.
interestingly about this system, though, the planets are actually quite far from the star. They're something like 5 to 10 times further than Neptune is from our sun. So these are pretty distant,
So the heat
big.
force is because it's forming,
I
it's the
think
heat
so.
of formation.
Yeah.
Yeah. And so does that mean that there may have been a phase like that for our own big planets?
It's certainly
Is
something they
this?
should be studying, right? Yeah, to understand, what was going on, what kinds of materials could have been evaporating and cycling through the atmospheres of Jupiter and Saturn and Uranus and Neptune while they were forming, and then maybe ultimately settled and contributed
Yeah.
to the more solid cores that these
Because
planets might have.
one of these is several times more massive than Jupiter, right?
Yeah, it was
This
something like
exoplanet.
14, I think.
Yeah. So that's getting up there, getting up to as big as planets get before we decide to give it a different name. Audrey, what's the answer on sand?
I think you're right. Sorry, I'm muted. Yeah,
Yes.
but yeah, medium sand is like about 100 to 200 microns, which is a
Ah,
lot smaller than I thought it would be. But
yeah.
oh well.
If you go to a, hardware store place that sells like sandbox sand, it will be larger
Oh,
than 250 microns because they want to make sure, maybe it's 150, but something like that to make sure there's no respirable
Yeah.
components
yeah,
because you really don't want to inhale silicate. So if it was actually cloudy with a chance of sandfall, and if it was, 100 micron or less than 100 micron in size, that would be really bad for your health.
yeah.
But one thing
Yeah.
that this paper reminded me of, Josh, is that this is a lot of the types of stuff you study in your labs, which is understanding sort of the circumplanetary disk and seeing these kind of small, more solid particles and whether they can kind of build
How they
up into these
interact.
bigger planets or
Yeah.
yeah, what kind of forces are needed, what critical mass, what critical gravitational pull do they need to come together versus kind of stay in this regime of being
Or how,
tiny, tiny, tiny things versus growing and growing bigger.
or
So,
yeah, or how sticky they need to be.
yeah.
Okay. So 10 to the 44 joules is a whole bunch of energy. It's the total
So
amount of
much
energy the
energy.
sun is going to radiate in its lifetime. It's the energy of a supernova explosion, which is one of the most cool explosive thingies out there. What's the name of that unit? Is it a beta after Hans Bethe, a foe, a whopper, a slam, a chandra, or a crab? I'm going to start arbitrarily, but not arbitrarily, with down quark, Audrey Martin.
Whopper.
A whopper.
Hmm.
Tracy, what do you think?
For some reason, I think I've heard the word slam as a unit.
Unit.
But if
Okay.
that's wrong, I sound silly, but that's all right. That's what I'm going with.
I, I think that's cool. That's fine. We got one whopper, one slam. Jim, what's on your menu?
Well, I know the answer, but I have no idea where it comes from, so I'll look forward to you telling me that. It's a foe.
You are correct. And I actually would have also accepted beta because recently I think Weinberg didn't really like the name Foe, and proposed that it be renamed Beta in honor of Hans Beta after he died. And so you could use either, but Foe is the answer, and it stands for 51 ergs, because 10 to the 44 joules is 10
Ah.
to the 51 ergs.
Oh my gosh. I didn't know that. That's
Yeah,
excellent.
yeah. So
That's excellent.
yeah. So, well,
51.
you learn something every
Learn
episode
something
of
every day.
Walkabout the
That's
Galaxy.
awesome.
May not be anything useful. In fact, it's likely not to be
Yeah.
useful. But yeah,
I'm
yeah,
now going to use every time I measure anything, even in like a physics 1 class, we're using foes for energy.
This is
yeah,
making me hungry.
yeah.
Yeah, I'm getting hungry too.
Well, that's what. Maybe you were already hungry, and that's why you said a Whopper.
Hmm.
That's probably what
Yeah.
it was.
Well, I feel pleased that I was able to make up arbitrary unit names that stumped both Audrey and Tracy there. Well, while it may have felt like getting slammed by a meteor, it was just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Jurusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in New York City. I'm Jim Cooney.
I'm Tracy Becker.
I'm Audrey Martin.
And I'm Josh Caldwell. We're the astroquarks, signing off until the next episode of Walkabout the Galaxy.
Woohoo!
Slam.
Whopper!
Slime.